For part A, you had to use that little formula to figure out what your other derivatives were. So, and this I think was the hardest part. So see here, they gave you the evaluation and the first derivative, so that means that the next thing we're looking for is the second derivative. And to find the second derivative, we would have to think something plus 1 equals 2 for the second derivative, which means that for the second derivative, our n value is 1. So that means for the second derivative, we have negative times 1 multiplied by the first derivative evaluated at 0. So I had negative 1 times 1 equals negative 1. Then for the third derivative, that's f of 2 plus 1. So that's negative 2 times the second derivative evaluated at 0. So I had negative 2 times negative 1 equals 2. And then you can go to the fourth, but I don't think you do need to. So then I had negative 3 times 2 is negative 6. And so then I went up here and I just set up the problem the way we know how to write these polynomials. So I had 0 plus 1x minus 1x squared over 2 factorial plus 2x to the third over 3 factorial minus 6x to the fourth over 4 factorial. I think you do have to simplify that since you're showing that these equal, but I'm not positive. We'll have to look and see if when we score the student samples, if that helps us at all. And then your nth term is, or your general term, I mean, is negative 1 to the n plus 1 times x to the n over n. There's your general term. Okay, so for part B, they said to determine if it converges absolutely, conditionally, or diverges, and that gives you a clue. Hey, come on in. That gives you a clue that you are using the alternating series test. Is that what you wanted? I'm assuming. Yeah. And Roche, you can take, Isaiah, you want to take your feet down? Yeah. You can take that desk and then just slide it out in the hall. Marvelous. Sorry, Isaiah. Oh, man, it's rough. Life is rough sometimes. All right, so when they tell you that you're checking if it's conditional or absolute convergence, they're kind of giving you a clue because the only test that checks for that is the alternating series test. That's the only one that would have those three options. So that's one of the things you're checking for. So here I went ahead and it says that x equals 1, so I plugged 1 in for x. And I noticed that gave me 1 to the n, so then I can ignore that part. And so I have negative 1 to the n plus 1 over n. And so I went ahead and I did the alternating series test on it. And I found that the limit as n approaches infinity of 1 over n is 0. And I found that 1 over n plus 1 is less than or equal to 1 over n. So it satisfies both of the pieces of the alternating series test, so that means it is convergent, but we don't know if it's absolute or conditional. So then you have to consider this series, but not with the alternating, just with the 1 on top, 1 over n. And that diverges because it's a harmonic p-series. So that means that this series that we have right here is conditionally convergent. That's what you should have. Okay. Is this the easiest series question that I've seen for the FRQs? No, it's not. All right, some of them are easier. This one happens to be just a little bit more tricky. All right, part C. So this one, you had to be, in my opinion, they wrote it in a confusing kind of way. I felt uncomfortable when I looked at this part, but you just have to think about, how do I integrate things? How does it actually work? So here, I went ahead and I wrote out my f just so that it was written right there. And then they said that g of x is the integral from 0 to x of f of t dt, which meant that I had to write f, but I had to write it with t values. So I went ahead and I wrote it all out with t's, because they said f of t dt. And then I went ahead and I did all my integration rules for all the pieces. So I had t squared over 2, minus t to the third over 3, but I still had that 2 on the bottom, plus t to the fourth over 4, but I still had that 3 on the bottom, minus t to the fifth over 5, but I still had that 4 on the bottom. Does that make sense? Okay. And then the nth term, be careful with this because I know this is what, when we did this, you guys had a hard time with these nth terms or these general terms. So just think about how integrals work, how it works to find the antiderivative. your coefficient is going to stay as a coefficient. So the negative 1 to the n plus 1, it stayed. I didn't touch it. My exponent has to go up by 1. So it went up and I have n plus 1 now. The n on the bottom is going to stay there because that's part of the coefficient, but I have to divide by my new exponent, so I divided by the n plus 1. So I did the exact same rule, I just have it all in terms of variables, which makes it feel a little bit more confusing, but the rules that we learned still work. Okay? Then I said I'm evaluating that from 0 to x, because that was our integral, right? And so if I do that, that basically just means, okay, now put it into x's and you're good. So I went ahead and I wrote that. I did all these denominators simplified, but you could have left it as 2, 2 times 3, 3 times 4, 4 times 5. That would have been fine. Okay, so for part D, now you have to be careful. If it's not Lagrange, I'm pretty sure you have to say it's an alternating decreasing series, therefore I can do this. I think you have to write that somewhere. Okay? It's not written in the first line of mine because I did not write that. So I went back and I wrote that after the fact. So I said my error is less than or equal to, here's my next term. So they asked, this is the 4th polynomial, so I'm looking at my 5th term. Okay, so I've got negative 1 to the 5th, it's inside absolute value sign, so I'm basically going to ignore that. I have 1/2 to the 5th, which is 1 over 32, and it's being divided by 20. So I had 1 over 32 multiplied by 1 over 20. You should be okay even if you don't simplify this. You should be able to just write this and call it good. But if you keep simplifying it, you find that the error is 1/640th, which is less than 1/500th. And so you know your error is what it should be. All right, now that we've looked at it, are we saying maybe it wasn't as bad as it seemed? Yeah, and I think it's easy. This is I think this is where you realize it's easy to psych yourself out and shut down. And the hard part about FRQ number 6 specifically is to not let yourself shut down. Is to say for instance, part C, it looked nasty, but it really wasn't that bad. It was like exactly what you would have thought it was. Is like, it says f of t, so use t. It says evaluate it from 0 to x, so evaluate it from 0 to x. Like, it really was all the steps that just looked weird. So when you are tempted to feel like, I don't like this, this is not going well, I don't care, don't do that, don't shut down, because remember, how many points are your goal? 3 to 4, that's our goal. Okay, so if you can get 3 to 4, that's what we want to do. So we're always going to go for those easy points, right? Those setup points. If we can get them, we're going to go for them. All right, let me give you the rubric. So for this one, for part A, you have the ratio test. And so I don't remember if we talked about this or not, but when I talked to my friend who grades the AP exams, she said that you don't have to do n plus 1 over n and then keep change flip. You can just directly go into this. And if you want to not put the negative because the absolute value sign would have taken care of the negative, it's fine for you to ignore that negative. Does that make sense? Okay, those are things you would not get graded down for as long as you worked with them correctly. So I started with this, and then I knew that the x to the n and this x to the n would cancel and it would leave to x to the 1. I knew that this negative 3 to the n minus 1 would cancel with that n minus 1 and it would leave negative 3 to the 1. And then the n and the n plus 1 I can't cancel because they're not the same. You have to leave them. So I said negative 3 to the 1, x to the 1 times n over n plus 1. The limit, as n goes to infinity, the n's are the same size, and so my result would be just 3x, and that's positive 3 because of the absolute value sign. So I know that this is going to converge if it's less than 1. So 3x is less than 1, which means x is less than 1/3. Maybe it equals 1/3, maybe not. But all they wanted was the radius of convergence, and so that's just 1/3. All right. For part B, I went ahead and I wrote 2 extra terms, but you only need 1 so that you can find 4 non-zero terms. So the extra term I found was 27/4 x to the 4th, so that I could take the derivative of that. So I had 1 minus 3x plus 9x squared minus 27x to the third, and then I had an extra. And then your derivative would be negative 3 to the n minus 1 times x to the n minus 1. And the reason there's no more n on the bottom is because you always, with the derivative, take the exponent and bring it to the front. So when you take the n and bring it to the front, that n in the front and the n on the bottom cancel each other out. And then you drop that exponent by 1. So that's where the n minus 1 came from. I did not get the other part. I wrote this. I wasn't sure if that's what they wanted. When they said write it as a rational function, what they meant was that if you put these two together, you have two different bases with the same exponent. You can think of it as negative 3x to that exponent. This is a geometric sequence or a geometric series. So that's your R. So then we can use that sum formula. If you were to write out all these terms forever, that would be a geometric series. So my first term is 1. I've got my first term divided by 1 minus r. That's what they meant by rational function. Yeah, when I saw it, I was like, ah, dang. All right. For part C, the Maclaurin polynomial function, blah, 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 whatever we call it, is 1 plus x squared over 2 factorial plus x to the third over 3 factorial. For g of x, you have to multiply that times f of x. And if you consider those like chunks, that means you have to FOIL them together so that you can multiply them out. Now, you don't have to multiply, like you don't have to FOIL everything completely for a really long time, like for all the different pieces, because you're only doing a third degree. So you only need the terms that have an exponent of 3. Anything that has a bigger exponent you can ignore because it said third degree. So I started off with the 1. I said 1 times x is x. I multiplied that, so that's where my first 3 terms came from. Then I had the x. I multiplied it and got x squared. I multiplied it and got negative 3 halves x to the third. When I multiplied it by the third term, I had a term that had a bigger exponent than I needed, so I crossed it out. I ignored it. Then I took the x squared over 2 factorial and I multiplied it by x, but then when I multiplied it by the other stuff, they were big enough I didn't need to think about them. So I ignored them. I didn't multiply this one at all because all of those terms would not have been needed. And then from there, I went ahead and I combined my like terms. So that's how I got x. I had negative 1.5x and positive 1x, which is what gave me the negative 1/2. And then for the x cubed, I had positive 3 minus 1.5 plus 1/2. And that's where I got positive 2. Does that make sense, how I went through and found those? So again, not the easiest process, but part C, the only calculus thing about part C was actually that you had to have memorized that Maclaurin polynomial. The rest of it was just algebra. It was just algebra you haven't been asked to do before, right? So we know how to multiply things out. We know how to FOIL. We know what third degree means, but you've probably never been asked it in this way, and that's what made it feel like a stretch. But if you keep yourself from panicking, it's something you could figure out. You guys are all mentally capable of it if you keep your brain calm enough to get there. Okay. You guys had asked for the test on Friday how many FRQs or what points you need to get the A to get the B. So to get an A, you have to have an average of a score of 5. That's average. To get a B, you have to have a score of 3.5. Okay, this is a little bit higher than you'll need for the AP exam because on the AP exam, your multiple choice will bail you out. Your multiple choice scores will make it so your FRQ scores can be a little bit lower. Okay, all right. We got about 15 minutes left, so I'm going to say let's go ahead and do the last one.